previous video, we talked about pandas, data analysis, and just a brief introduction into what we'll be working with. So this time, I'd like us to talk about how to actually do data analysis. And again, we're going to continue to use our semi-real data set, and we'll use this data by exploring it, transforming it, and ultimately, and probably in the most exciting part of it, build visualizations with Pandas and Seaborn. There's a few commands that we're going to need for this. We already have one of them in here, but I'm going to go ahead and create a new project here, or not project, but just a new Python file so that we can start over fresh. So let's go ahead and open this, and we can rename it to data analysis 2. And let's import. First, we're importing what we already know, pandas, because we do use pandas a lot and we will continue to use it. Now let's import something else. Let's import matplotlib, which is really good for data visualizations. So specifically, we're going to ask for PyPlot. There's our abbreviation there, so we don't have to type PyPlot the whole time whenever we want a new PyPlot. And then finally, we're going to import Seaborn. I'll go into Seaborn in a little bit more detail as time goes on. But for now, let's just leave it at that. So let's start with how you would go about examining a piece of data. To do this, we would always start by asking, what do we want this data set to look like? What's the shape of the data? We want columns, rows, row counts, data types, and a quick statistical snapshot, which we took a look at last time, right? We saw that in our read here, or looking at the head, or getting a deep view. So there's many different ways that we can reformat our data to kind of make sense of what we're looking at. And we've got this describe here that's describing in depth what the shape of the data looks like, kind of, and where the most data points are. With that review in mind, let's go ahead and get started on some data visualization. Chances are, in the past, you've seen some form of data visualization. A lot of times we see it as a line plot, or a bar chart, or a pie chart, but it's basically just a synopsis of the data that you already have. And it can be really helpful if you need to communicate something about your data in a short period of time. So something where you might have seen this recently would be a weather application where they use the highs in a bar or line plot sort of visualization, but it's useful for you when you need to communicate something to a coworker or a manager and basically just quickly show them a conclusion that you've drawn about the data. In order to do this, let's go ahead and start with a line plot, because I think that's one of the simpler visualizations that we have. But I did notice that I am missing something here. And I said it, and then I didn't type it. There we go. And now I'm going to save this. Is it going to let me? Okay, well, I would like to rename this. I want my data frame back, because we spent a decent chunk of time looking at this data set and explaining how it worked in the last video. So I'm going to put this here. I'm going to let you have a look real quick in case you need to get caught up. But basically, it's going to help us read in all of our data. Now I'm going to run this so that it's in our notebook's current kernel. And now we can start working with this. Let's start by sorting it. We're sorting by index here. Whoops. And now let's create a variable for specifically the hostname ws-001, which I'm going to name ws1 for simplicity, and also because certain Python applications tend to freak out a little bit if you use special characters. I'm not sure if that's part of the compiler for Python, but anyway, I digress. So here we're saying, look at host names, and specifically, I want you to look at the host name that is equal to ws 0.001. Here we go. So now we're going to take a look specifically at WS1's uptime hours. So this is saying just for this device, go ahead and take a peek. So plot this for me. We're saying what version of a plot do we want? And let's make a title that makes sense. It's the same as it's the same as when you name a variable. So we want the variable name to make sense for what we're doing. So here we're going to say, well, this is common etiquette in science. I'm going to say x-axis versus y-axis. So uptime over time here. And then the device that we're looking at. And we're going to plot it. So here's our X label, which is the date, and our Y label. You know, done all this math in my life and still I have to think about which one's the x-axis and which one's the y-axis, which sounds so silly, but sometimes you just got to think about it for a minute, you know? No shame. I will not have any shame in my math. And there we go. That's pretty cool. So you can see it tells us the uptime, the number of hours we have over here on the x-axis. So you can see as labeled in our little plot code up at the top, we've got hours on our y-axis and date on our x-axis. So that's saying what date, what did this happen on, which date is a very common X label to have, and then how many hours of uptime were there on that day. So we can tell at some point they had very little time on the computer, but for the most part, the number of hours running is high. And even here, it's a little bit misleading the way that this graph is set up, because you can see the lowest we get to is 18 hours, which is a high uptime, right? 24 hours would mean it was running the entire day. So this computer has been running a lot, but let's say we just change this. What happens if I decide that I want a bar here and I just put bar? Now Python does that, but if you take a little look there, that doesn't make any sense for the data that we're doing. I mean, it's fine, but which one do you think is easier to read for the data? Like, what are we trying to communicate here? First of all, we're trying to communicate the amount of uptime. And then second of all, we're trying to communicate the dates. So the interval of dates that we have here would be a little bit overwhelming with the bar chart. So my point is just kind of different data has different graphs that are sort of meant to be used to model that data, and it's up to you to decide what the right one is for you, so to speak. Anyway, I'm going to put this back to line because that's what I want. And now we're going to take a look at a different set of data and try a histogram. You've probably seen a histogram, even if you don't know the name of a histogram. So let's just type it out and let you have a look for yourself. For this one, I want to look at CPU usage percent. And then bins, what does that mean? You're gonna see. Unless you already know what a histogram is, in which case you probably have a guess. Again, we need a title that makes sense for the situation. And let's show it off so we can see it right away. So when I run this, you can see that we've got our frequency here. And then at the bottom, we have got intervals of 20. And it's showing the frequency, so the number of times that the usage is at what percentage, right? So the most CPU usage was probably at about 50%, and it happened almost 40 times. So that's useful for us if we need to see the distribution of data points for a specific device, right? Like if I wanted to see what the average usage distribution looked like over a number of days, this would be helpful for me. Or if I wanted to look at a different data set and I was looking at employees, and when I say the CPU usage that is highest, I don't literally mean the CPU usage percentage. I should correct that, because the highest usage that we see is at about 90%. But what I'm really saying is the highest frequency that we see of CPU usage percent is going to be at 50%. So part of, or I guess another part of the visualization skill is just understanding what it is that you're looking at when you're looking at this data set, A, and more importantly, B, what that data is communicating to you. What does this mean for your computer? So this means to me that this device is usually at a pretty healthy level of CPU usage. I've seen CPUs jump to 70% over something silly. You have too many tabs open, you have too many programs open. That happens, even to 90%. And maybe if it were hanging out at the 25 to 30% range, I would be worried about about that. Like the frequency, if the frequency jumped, I would be worried about that. But given the low amount, I doubt that CPU usage is part of the issue. Looking a lot more like uptime might be the issue here, just from the graphs that we're running. With that in mind, let's go ahead and explore another plot here. Let's take a look at a box plot. I know we're back to school here with all of our plots, but here we're going to say what we want for the columns. And this is just, instead of the frequency, we're going to look at the health status. And then this one's even more obvious than the previous ones because it literally says by. So you can say CPU usage by health status. It's already written for you. And let's have a look at what this plot looks like. There you go. Okay, so these are a little bit harder to read, but they have a lot of useful information in them. So what can we see here? We can see outliers, maximum, the upper quartile, the median, the lower quartile, the minimum, and then lower outliers. So to start with, let's look at our upper circle here. Our upper circle is our outliers for the upper quartile. So they have to be more than 1.5 times the upper quartile. And then we have the maximum. So this would be our maximum. So if you look with warning, the CPU usage, that outlier is way high. It's at like 90% compared to the maximum that we see within the, like excluding the outliers. The next one that we see is at 72 or 73. And then once we get past that max, we can look at the upper quartile. So this is the top 75%. So from here up to here is 25% of the data. And this line here is our median. So the median is 50% of the data is greater than this value. This is the middle of our data set. So the middle of our data set is at about 50, which makes sense. And then our lower quartile is here, which if you notice, these are not equally spaced because they don't have to be. It's just about how your data is distributed. So the bottom one is the lower quartile. That means that 25% of the data is less than that value. And then we see the minimum, which is the lowest value excluding the outliers, and we don't actually have any lower outliers here, but we see a couple in the healthy area. Now, in this case, we have to be critical about what exactly the data is that we're reading and interpret it. So for a healthy computer, it makes a lot of sense that we would have a very low CPU usage for several of the devices, because it looks like we have a couple devices maybe that are overlapping each other in the healthy space. So those devices don't really use a lot of CPU usage consistently, or they're experiencing lower amounts of usage than the warning status ones at their base or even the critical ones. And you can see that our data does make sense. It kind of trends upward as the health of the device decreases. Interestingly enough, we see a dip in the upper usage here, but we see a very high outlier, which makes me wonder what that means for our CPU usage overall with a warning on a device. But with critical, it definitely aligns with what we were expecting, which is that we have a very high upper limit, although I will say that our upper quartile is lower on critical. So what that tells me is that it's possible that the health status is not directly influenced by CPU usage. It does seem to be correlated. There's some form of relation, but I'm not sure that this is a causation situation. I'm not sure that our CPU usage is causing negative health status. So now that we've had a chance to take a look at our data visualization basics with Pandas, I would like to delve a little bit deeper into those, but also explore a new technology, and that is Seaborn. Now, don't get me wrong, there is absolutely nothing wrong with Pandas. It makes great visuals and is wonderful if you need to use it with your existing data and just create a quick visual. However, Seaborn does offer more variance and can tell a better data visualization story thanks to its arguments like hue or size or style, and it also is helpful when you need something that's multicolored and can help you visualize your data better. So it's a little harder for you to see that or understand that without me showing you an example. And I'd like to give you an example of both a new type of plot in Pandas and that same plot in Seaborn. So let's start with the Pandas version. Okay, so we have this set of arguments, and we're going to ask it to show the plot. When we run this, here we go. Now there is nothing wrong with this, and it looks visually like it makes sense. We can see here we've got memory usage percent and CPU usage percent, and we're just looking at a plot of the two of them. But let's try a same scatter plot in Seaborn. In case you're wondering where this SNS is coming from, it's coming from our initial import statement here, where we say import Seaborn as, which is an alias SNS, and that's to make it shorter and easier to work with. And then immediately we're going to say, take the data from Pandas. Let's not bother trying to re-input it using Seaborn or reinvent the wheel. Let's just use our Pandas data from the jump. Oh, I don't like how that's spaced. Hold on. So I know this looks a little different, and we're going to see why in just a minute here. So when we run this, you can see that it's showing us the same stats as it was before, and the data looks just the same. We can see here there's one much lower stat, and there it is right at 40. same spot for both of them because they're plotting the same data. But also we have health statuses and their colors. So we can see based on this data that there's a warning device that has 100% memory usage percent, but very low CPU usage percent. And we know that that same device exists right here, but we don't know the health status of that device unless we were to be here. So you can see how Seaborn helps us with data visualization because it can give colors or things that visually tip us off as to what's happening in the data. For our next venture into our plots here, let's go ahead and add a trend line with regression. So you'll see what this is when I implement it, but it's unique to Seaborn in that we can only get this without calculating it if we use Seaborn. We would have to calculate it manually in Pandas and then plot the line manually as well. So again, we're saying pull our data from the data frame that we already have existing in Pandas. Hit the wrong button. Let's go ahead and give our plot a title here. It's going to be very similar to the one we had last time. Okay, and then when I run this, here we go. So it looks like there's just this line interrupting all of our data, but what it's actually telling us is if there's any form of trend. So this might not be the strongest case for regression because if you look here, you can kind of see the data is very scattered. There isn't necessarily a trend, but if we were to try and draw a trend from that, we would say that as memory usage increases, CPU usage, well, actually, no, that's not true. No, that is true. As CPU usage increases, memory usage decreases. So that's just kind of a quick glimpse into what might be happening, but this trend line in particular, you can tell might not be the strongest case for this data because the amount of spread that we have here is pretty high, and the number of points that fall in line with our confidence interval, which is how confident we are that the data will fall in this amount, is not super high. There's a lot of data that exceeds our confidence interval there. If you want to learn more about confidence intervals, I would say take a statistics class because they go into that very heavily in statistics. But yeah, this is a good starting point if you think that there might be a trend to a piece of data and you want to just track it and see if there is anything there. And that's kind of the gold mine with data analysis is sometimes there is something there and sometimes there isn't. But either way, if you can uncover a trend, it will greatly help you determine what might be going on in the data. And of course, there's the concept of correlation without causation, right? So two ideas might be related, but one might not cause the other. So just be aware of what you think your data is trying to tell you and making sure that that is accurate. But anyway, if you had data that this would be useful for example, maybe like an age of computer to amount of time that a computer takes to boot an application, which I have seen in certain data gathering situations and systems, usually we do see a trend where as the device gets older, it takes longer to boot and to run softwares, right? Which just makes sense. We know innately that that is possible and even likely. So you could use a regression line there to show that there is an overarching trend that is evident in your data. For this next one, we're going to take a look at the Pandas version first and then the Seaborn version of the same graphs, just so that you can see kind of how much work Seaborn is doing for us. So let's start with a Pandas bar plot. And I think we might have seen a bar plot, but just in case, we're going to take a look again. And while we're at it, we're also just going to add an extra manual aggregation. So sorry, also this is a string. Let me add that back in there. So here we are. First, we're calculating the mean. So we're not doing it to the same level as like calculating the mean for ourselves, right? It is automated. So Pandas is calculating the mean for us, but we are having to tell it, okay, go ahead and calculate the mean on a different line from our graph here. So now we can make the graph, which is our plot here. When I run this, oh, it didn't like it. Oh, future warning. Okay, so it's just saying that this will be deprecated at some point. But when we give this a quick shot here, you can see we've got healthy, warning, and critical. And they're all looking pretty similar. I mean, you can see there's a slight height difference between warning and critical and healthy, but it's not that dramatic. But it does show us that there's a slight difference, which, again, a big part of data analysis is just asking questions and seeing if those questions lead you anywhere, because sometimes they do lead you in the direction that you need to go and sometimes they don't. So you got to just take what makes sense and leave the rest. So this is what we're seeing. But notably, we can see that this is the mean, right? So this is on average what our devices look like. And now let's go ahead and do this in Seaborn. And as you see these side by side, you can kind of see the difference in the way that they're structured. So for example, they're comma separated here. And you also don't have to do this the way that I'm doing it. You can put them all in one line at the same time. I just like to separate it by commas because it can, well, JupyterLab can correctly assess where there are breaks, and I find it to be easier to read for me personally if I have each argument on a separate line. But again, totally up to you. Doesn't matter. Space them as you like. You also, if you're used to having like all backed up like this, you can do that. You don't have to space them out like this, but again, for human readability, it makes the most sense to me to space out what I'm doing there. So we're looking at health status, CPU usage percent, and now let's tell it to use the mean as our estimator. So, whoops. We're not going to calculate it. We're just going to have it do that for us. And as you can see, we also didn't store the mean here. So even though we did calculate the mean, we aren't pulling that here. Seaborn just already has the mean for us, which is nice. We're going to give it the same labels that we gave our pandas, because it's the same style of graph. Oh, whoops. Ran a little too quick. These are just for the layout and then telling it to show it. Well, it looks like it did show it. So, oh well. We run this. Here's our big reveal. Wow. So you can see we've got not only healthy, warning, and critical, but we've also got our mean here. We're using that as our estimator. So it adds the error bars to show like the uncertainty that we have. So I misspoke, but basically that's, again, our interval. And it's showing the confidence intervals by default, which again is a pretty basic concept in stats. And like we saw with pandas, you'd have to do that yourself and manually draw the error bars. So we aren't given those error bars automatically here. And you can see they're just a little bit stylistically different. Like I've asked it for the tight layout. So it's kind of narrowing in that data more so than here. But yeah, as you can see, it tells a little bit more of the story with a little bit less of the work. We've already taken a bit of a look at Seaborn versus pandas and how they can be advantageous one over the other, but I want to do one more example that will convince you of Seaborn's strengths, and then we can go from there. So to start, let's make a grid. And this is going to return type facet grid, and we'll see why. Now, a lot of the documentation examples for this use G for the word grid, where I've used the word grid here. You can call it whatever you want. However, I think that grid is a little bit more explanatory. So if you're looking through the documentation of Seaborn, you might see G, but I'm going to call it grid. And we've used single character variable names like X and Y, but the only reason I used those is because I felt like they were pretty self-explanatory given that we are using the X and Y axis. We're almost there, so let's go ahead and show this now. Oh, there we go. Okay, so it took us a minute, but you can see there's a big variety of data here. And let's see if I can zoom in a little bit here. Oh, I can, but okay, well, it doesn't want to let me, but that's all right. Oh, there we go. So this is kind of the sweet spot, but you can see we have all the different hosts and their uptimes. So this is a more complicated question because we're looking at the amount of time that a host has been online per day and the days, which is pretty interesting because you can see there's a significant difference here. Now, that question of how would I measure the uptime hours over time split by host is interesting because it gives us a chance to figure out what is going on with our hosts. And you can see the names or the dates are a little bit jarbled here, but I think they're supposed to be spread out throughout. But anyway, yeah, this more complicated question is much easier to do in Seaborn than in Pandas, because in Pandas I would need to find ways to write loops, manage the axes by hand, and keep track of subplot indexing, which is a lot more complex. So if you're looking to answer more complex questions quickly, I would definitely recommend Seaborn as a tool. Now I'm going to go ahead and reset our stuff here. But yeah, quick little introduction to Seaborn for you. Now that we've covered relational plots, scatter plots, box plots, bar plots, regression plots, you name them, we're moving on to some other required visualization skills, which are categorical distribution plots, frequency plots, fold distribution plots, and plot enhancements. These are going to help us analyze how different system health behaves in our data set in our case. And more importantly, it's going to help you gain the skills that you need to visualize what goes into a good data set and what questions you need to start pulling from your data. So first, let's take a look at two categorical plot types that you haven't used yet, the count plot and the ViolinPlot. So the count plot is going to tell us how often each health status occurs. Let's go ahead and type this out right now. And again, we're going to hit it with our Pandas data frame. We're going to use health status again. Actually, I take that back. I just need this. And then... So we're only comparing two things that our data inherently has. Well, one thing that our data inherently has, and then the other thing is a count of what our data looks like, which I'll show you here because I don't know that I explained that perfectly, but... So that's our health status. That's what we already have. But now our Y label is the count. So this is counting how many times each health status comes up. And then doing that tight layout again. And we're going to show it just in case, because sometimes it doesn't show up, which is kind of wonky. And I don't really know why it does or it doesn't. But anyway, we run this. Look at that. So we've got a lot more healthy devices than warning devices, and we've probably got almost double the warning devices to critical devices. So you can see right away how this gives us a different insight into the data, because we didn't actually know, like looking at this distribution of data, you might be able to see just from looking through it that, yeah, the majority of them look healthy, but you don't know just how big that cap is, or the space between a healthy device count and the warning device count. So this is really good if you just need a quick insight into how many devices are actually having issues right now. One more thing, technically you don't need to add the title or the X label or the Y label, but for your sanity, the sanity of the people around you, and the quality of your work, I'm going to say that those aren't optional. They technically enhance your visualization, but you really need them. I mean, if I were to take count away and you couldn't see that, what would you think that this is about? Sure, it says frequency of health statuses, so you might be able to guess frequency, meaning the number of times that it happens, if you have the title. But if I took everything optional away and I just had X here, it wouldn't use it as a label. So we would have no labels on anything except for the health statuses at the bottom. And that would be much harder to parse than just being given our X's and our Y's. So try to be aware of what it is that you are saying with the visualization that you're offering based on your X labels, Y labels, and what you're asking of the data. Now let's go ahead and move on to a ViolinPlot. The ViolinPlot shows the full shape of the data distribution, not just the median, which we see in our box plots. So this would help us with, in this case, the question I have, does critical health seem to correspond with higher CPU usage? We were talking about that earlier, and the idea of causation and correlation and whether or not two ideas are linked. So let's go ahead and take a look at this. Oh, also notice the larger font size here, which is good. Oh, okay. But to have that set in stone, I'm going to go ahead and set the style and the context, which I believe we already have the style that I want going here, but I'm going to show you how to do it in case you want to change the style to something that you prefer. Maybe you work in an IT setting like me in the dungeon, and everybody likes to work in the dark. And that means that if you show them this screen, you flashbang them. So you don't want white grid. You want something in black, right? In this case, it's easiest for us to see on a white background. It's best for our visuals, but do what you think is right based on the current aesthetic and needs of your report. So we're doing white grid, and then we're going to set context for talk. And what that means is we are making the text larger so that it's easier to read. Once again, we're going to look at our health status. I feel like health status is a good question to be asking about, because health status is an indicator of a lot of different factors. Like it's the most overarching factor of all of these pieces of data that we're being given. So it's good to compare it to other things in our data, because it feels like the most comprehensive piece of data here. And now we're going to do our usual enhancement here, which is a title, although again, not really an enhancement. I would argue you need this. And here are X labels and our Y labels across the X and Y axis. Full disclosure, I can't see my hands right now, so I'm just going to write % instead of finding the percentage sign, which is why we're doing it differently this time, in case you were curious from previous times. It's on my keyboard right now. In my keyboard tray, I should say. So when we run this, there you go. Now, this gives us the density. So when you see a wider part of our data, that means that there's more data points falling within that range. So like our most frequent areas are right in the middle, right? Which makes sense. Because if you think about like a bell curve or the way that data is typically distributed, it's going to be more frequent towards the center and then oftentimes less frequent at the two extremes. Not that it's always that way, but oftentimes data does tend to look that way. I know we've already spent a lot of time understanding what a box plot looks like, and truth be told, this is a very similar layout to a box plot. So the thing that you really need to understand is that a ViolinPlot does a better job of showing the frequency of a particular data point. So if you had maybe like critical devices had a ton of devices happening at the 40% mark, you would say, oh, it's really weird that that's happening so much. I wonder if there's some program that's eating up roughly 40% of the CPU, available CPU processing power, and it's impacting the device health overall at the same time. So if you were to see something that was super frequent at a very specific data point, that might tell you a little bit more. I would argue that, and this is just personal opinion, but the ViolinPlot is maybe a little bit less clean looking than the box plot. So if you don't find any major conclusions from the ViolinPlot, it's better to use the box plot. But if you do find something significant, then it can be really good. And as you can see, it takes all of 2 minutes to run this. So you can get a very quick insight and decide, do I prefer this to the box plot? Is this something that I want to take or I want to leave? And then you can make it a decision based on all of the information. Let's go ahead and make one last histogram, which I know we did with Pandas, but we're going to go ahead and do it in Seaborn so that I can show you how to save your figure. So to start with, let's go ahead and make our plot, which is going to start out just the same as any other plot. And again, we're using CPU usage percent, just because it's kind of an easy, statistic to look at. We're going to give it this. Now, I knew what KDE meant before this. It meant, like, basically it means that it creates a smooth curve over the top of our histogram, which represents, basically it represents how likely each thing is to happen, but I didn't know the name of it, so I looked it up, and in this case it's called kernel density estimation, which is what it stands for, which is very useful for us when we are assessing how common something is and how often it shows up. I also realized I forgot to talk about something that I did earlier, which is here, which is share Y. So that means don't allow these to share the Y-axis. Don't allow some major overlapping that would make our plot basically unreadable. So sorry I forgot to mention that before, but now you know. We're going to do our same type layout. And now we're going to do plot.saveFig for save figure. We're going to give it a name. So I think I'm still gonna, well, I do like to keep my titles all one. I'm old-fashioned that way. I don't like spaces in my file names. And then I'm putting the name of the dataset that I'm using because I have multiple datasets that I could be pulling from. So I'm just quickly mentioning what dataset it's from. But I also need a type. So I'm going to do a PNG in this case, just because they save well and they usually show up pretty well. And then we're also setting a specific DPI. So DPI stands for dots per inch, and that specifically refers to the resolution of the plot that we're generating, which in this case is relevant because we're thinking, oh, we're going to save this image and we want it to be as clean as possible for our boss or whoever's going to be looking at it. Now let's save this guy, or sorry, we already saved it. Now we're showing it. So let's run that. And there it is. Which is good. So you can see our distribution here. Everything seems to make sense, and you can also see our trend line there, which again has kind of a bell curve shape to it. So that's what we would normally expect in a lot of data sets. But yeah, this is good for us to save so that we can pass on, and it's pretty clear and easy to read. So to me, this is a successful diagram and something that I would be willing to share with the people on my team. So if you're like me, you might be wondering, where did my picture go? Because I saved the picture, but I didn't see a little download pop up. I didn't see it go anywhere. I didn't get a visual cue that it downloaded. And the answer is it did save, but it didn't save to your device. It saved to JupyterLab. And here it is, right here. So if we take a look, here's our image, and it's nice and big, which is good for us depending on what you want to use it for. So try to be conscious of what you're using it for and use an appropriate amount of processing and resources to make the image look good for whatever context you're using it in. For example, if you're using it in a PowerPoint, you're going to need that picture to be better at higher resolutions and do well in the larger format. And then if you were to use that same image in a Word doc that you were handing out during this presentation, you would also want that to be at a different size while still being viewable. So just be conscious of the format and the form that you're going to be giving your image to your readers and consumers of your data when you give it to them. Anyway, that being said, we covered so much today. Good job. And I know this is a lot to take in, but for the most part, we talked about different forms of data visualization, which is kind of the most fun and fastest way to glean something from your data as possible. And it can definitely kind of open new doors for you as you see your data out and see how it's supposed to be. And that is super helpful. So I would recommend taking a look at all of the different Seaborn visualization techniques, because we definitely didn't use all of them. And there are more Pandas techniques as well that are also good. And I would suggest checking those out and reading the docs and just seeing how you can best use them and pull what you need from the data. But anyway, it's been super fun teaching you about this, and I'll see you guys later.